Hello everyone and welcome to my very first video in this YouTube channel. I'm David and on this channel I plan to explore mathematics through problem solving. I walk through solutions step by step, discuss different approaches, give you some advice how you can approach in different math problems, and I'll explain my ideas behind my calculations. I hope this channel will be helpful not only for people who are interested in math, but only on those who plan to study it in the future, maybe in the university, maybe in the high school. I personally am a student in the high school and I'm in my pre-last year. I'm in the end of my pre-last year. So the next year will be my last in the high school. I plan to study mathematics in university, and that's why I'm keen and I'm passionate about continue learning math in details. Through this channel, I plan to not only recall things that I maybe have forgotten because I've studied them long time ago, but I also hope this channel will be helpful for people who are interested in math, but sometimes they feel tired of it, they feel exhausted, they feel that they cannot do this, they cannot go through this. They actually give up on their passion and they give up on exercises. And I hope at least one person will be able to understand the concept behind different exercises, which we're going to go through in this YouTube channel. I will do random videos on random topics, but maybe I'm going to organize them in different like topics. Today, in the first video, and not only the first video, but maybe some at least this month, we're going to solve math problems connected with trigonometry. And specifically trigonometry, which here in my native country, Bulgaria, is studied in 11th grade. So these exercises are going to be from my 11th grade mathematics book, and they're going to be for the pre-last year of the high school. So, yeah. The next thing that I want to say is that my English can sound a bit unnaturally, but it's not my native language, so I'm not 100% sure that I am actually that fluent in terminology and specific vocabulary and terms that are connected to math. And sometimes, yeah, I can do mistakes, but everybody does that. So do not be distracted by my English or do not pay that much attention. I know that I evolve in the future. Maybe I'm going to feel more free to actually film to record these videos. Now I'm not that sure in myself, but I think in future I will actually get better, and I will become a better version of myself. So today we're going to begin with the first topic, which is the basic trigonometry, and this is the summarized angle, or also called radian. You know that the summarized angle is the angle for which is given the rotation, after which the first ray of the first ray takes the position of the second ray. So that's called the summarized angle. Of course, another thing that you know is about the radian. You know that 1 radian means that the radius of the unit cycle is equal to 1, and at the same time the arc, which belongs to like the central angle, which actually have a belonging arc, is having length which is equal to the length of the radius of the unit circle. So in that way, we should know that if the angle is 1 radian, that means that the belonging arc is also one angle, is also 1 centimeter, and the radius is also 1 centimeter. Or for example, if we have angle equal to 2 radians, that means that the the arc, the belonging arc, is 2 times longer than the radius. Or if you have 3 radians, the angle is 3 radians, that means that the arc is 3 times the radius of the unit circle. So if the radius of the unit circle, yeah, it's always 1, so that means the arc is equal to 3. Or for example, if the radians are 2, so the angle is 2 radians, that means that the arc is equal to 2. But if it's 1 radian, that means that the arc is equal to the radius of the circle. Now we start with the most, I don't know how to name them, but the most basic exercises. And we begin with an exercise which wants from us to write in the form A plus K multiplied by 360 degrees if alpha belongs to the interval from 0 and 360. You know, here we write a straight parenthesis because you know that 0 is equal to 360. They're the same value when it comes to unit circle. When you rotate the circle, you reach from 0 to 360, but 360 coincide with 0, so they're the same. So one of the values should be in the interval. So we choose the 0, and we should write in the form alpha plus k multiplied by 360 degrees, where alpha belongs to the interval from 0 to 360 degrees, the measure of the summarized angle. Yeah. And that's it. So we have the first example, or I'm going to call it subsection A. So subsection A is 660. How we can do that? So we want it in the positive form, that means with the positive sign. So the thing that we should use is some angle and one rotation, or some rotations. We will see how many rotations we can do. Of course, you know that k, the constant k, means how many times we rotate, and the a and the alpha angle is the remainder of this rotation. So how much degrees remain from this rotation? In other words, we can tell it like that. Yeah, we can think of it like that. So we begin with this, and on the first thing we are going to write for For example, because it should be plus, if we write it, for example, as 2 times 360, we are going to obtain 720. But we know that we want, and if we obtain 720, we will need to subtract something, but we need to add something. Yeah, we need addition. So we're going to do it. How many times 360 is included into 660? So it's included 1 time. So we write it like that. Angle alpha plus 1 times 360. So we have 360 plus how many is equal to 660 degrees. So of course, you know, that is 300. So 300 plus 1 multiplied by 360 degrees. And that's how we write it in this form. Now let's give another example with the subsection B. We have 750 degrees. Now we know that 2 times 360 is equal to 720, 707, yeah, 720. So we could write it firstly as alpha plus 2 times 360 degrees. Now we obtain alpha plus 720 degrees. We will again write it in these forms in this form later on because it's the correct form, because it's given like that. So we think how many 720 plus how many is equal 750. This is 30. So 30 plus 2 times 360 degrees. And that's the form we should write it in. This, I'm sorry. This and these are the forms because we want it with positive sign. Of course, we can do it with negative. For example, on the first one, we can do it as, for example, here, if it was given, write it in the in the form alpha minus k multiplied by 360 degrees, we would be able to write it as 2 times 360 degrees minus 60 degrees. So it's gonna be 720 minus 60 is equals 660. So it's the same, but this is if it's given with minus. Now it's given with plus, sorry about that. And we are obliged to write it with plus. Oh my god, what happened? Okay. Now subsection C, let's see, we have minus 60 degrees. So now, if we want to write it with a positive, we can think of it as some kind of a number. So what we should do to write it in this form? So of course, we can write it as, for example, 360 multiplied by 1, that's for sure, and alpha plus something. But it's not possible. It's possible only if the 360 is with minus, because you know minus 60 we can obtain only if we write 300 degrees minus 360 degrees multiplied by 1. In other words, this is the only way that we can write this. So there's no other way. So here we can use the minus sign, the subtraction sign. But in the other occasions, we could not, because we have the option to do it with plus. And because we are given in the condition of the task that we should do it with plus, it's better to do it with plus. So here we are actually allowed to do it with minus because it's the only way. So here it is how it's written. Again, let's move on to D and C minus 300. So degrees. Of course, we will have alpha plus 1 multiplied by 360 degrees. The only way for it is to be minus, is to be 60 degrees, alpha to be 60 degrees, and here it should be minus 1 multiplied by 360 degrees, because we will obtain minus 300 degrees. So here we are also allowed to do it with the minus sign. Now we're moving on to the last subsection, and that's subsection E. So we have minus 450 degrees. Of course, we're going to write it, for example, alpha plus 1 multiplied by 360 degrees. The only way for it to be correct is to do it like, for example, we can do it like 270 degrees minus 2 times 360 degrees. Yeah, in that way. Because in the other way, it should be minus, it should be, one moment, 360 plus 450. It's going to be a large number, so it's going to be something like, yeah, 810. So 800 minus 810 plus 360, but it's going to be actually harder for us to calculate this. So it's better to write it just as 270 degrees minus 2 times 360 degrees, which is 720. And 270 minus 720 is equal minus 450. Yeah, so that's the first exercise. Now moving on to the next 60 degrees, where k is the constant, or how many times we rotate the circle, and alpha belongs to the interval from minus 180 degrees to 180 degrees, which is included the measure of the summarized angles, minus 40, 220, 270, minus 300, and minus 550. Of course, here you should notice and you should be very careful, because we have a specific interval. We are limited. We are not allowed to work with all angles from 0 to 360 for the alpha. Now we are limited from minus 180 to 180. So if we imagine the unit circle, you know, here and here, we know that here is 180 degrees, and we know that here is minus 100, and we know that also here is minus 180 degrees. When we rotate clockwise, and when we rotate counterclockwise, because the positive rotation is counterclockwise while the negative rotation is clockwise. So yeah, so we are allowed to work only with these values. So now let's do the first subsection. So that's subsection A. Subsection A, we have minus 40 degrees. Of course, minus 40 degrees, how we can express this? We can do it as, because we cannot include 360, yeah, particularly in this, we don't need it because it's a small angle. So we can write it as minus 40 plus 0 multiplied by 360 degrees. And now we're in the interval. Yeah, alpha is minus 40. So this is in the interval. Here the angles, here somewhere here, maybe will be the angle 40 degrees. So we are allowed to use that. So subsection A is easy. Now we have subsection B. Because we have 220 degrees, we could not directly put that value because we know we are allowed to put alpha values, like to use angles which are from minus 800 to plus 800 degrees. So not 800 but 80, 180 and minus 180 and 180. So we use this. And what we can do? Of course, we can write it as 1 multiplied by 360 degrees. And now let's think of it. 360 minus how many equals 220? Of course, minus minus 140. So we're going to write it 140 minus, because this is going to be removed if we calculate, for example, the trigonometric functions, because we know this is the one cycle, so we remove it. And this is the form that we're going to write it in. We check our angle alpha. It belongs to the to the allowed values, because the allowed values are from minus 180 to 180. So that's correct. Now we are moving on to the next. We're moving on to the next. And for example, here for the previous one, we can do it also like minus 180 degrees plus 1 multiplied by 360 degrees. This is the other way because it will be more precisely, as here it's going to be with plus sign, which is important. Yeah, the plus sign is in the condition of the exercise, because 360 is a bigger value and the plus sign will remain, and we will obtain 220. So maybe the second way is the more correct one. So now the C example is 270. We know, again, we can write it as something smaller than 360. 360 minus 270 is equal to 800. No, sorry for that. It's equal to 900. So it's going to be minus 90 degrees plus 1 multiplied by 360 degrees. So it's in the positive form here, and here the angle is in the allowed values. It belongs to the values, yeah, angle alpha. Then we're moving on to the D example, and we have minus 300 degrees. So of course, 1 multiplied by 360 degrees, or in other way, we can do it like in the form like that, for example. Because we're going to obtain positive angle and we need negative angle. So the only way here is for the sign to be negative. Sorry for that, sorry. Oh my god, sorry. Yeah, sorry for that. So we're going to write it as 60 degrees minus 1 multiplied by 360 degrees. We are going to obtain minus 300. Yeah, degrees. So this is the way. And the last subsection, E, is given minus 550. So in this, we are going to use again, maybe because we want to obtain a positive as a negative value, we are going to use it 2 times 360, 720. 720 minus how many is 550? Minus 170. Yeah? So 170 degrees minus 2 times 360 is going to be 170 minus 720, and this is minus 550. And it's again in the allowed values. Yeah, the angle alpha is again in the allowed values. So it's easy. So that was basically the exercise. These are the basic exercises connected with trigonometry and writing the measures of a summarized angles in some specific form. Now the next exercise requires from us to express through radians the summarized angles. And the angles given are A 10 degrees, B 20 degrees, C 165 degrees, D minus 220 and 10 degrees, and E 315 degrees. So yeah, you know how we express an angle. For example, if an angle is 1 degree, we express it through radians by multiplying it by P over 180 degrees. And we obtain P over 180 radians. Yeah, this is the way how we can do it. So we just substitute this in our subsections, and it's so easy. So we begin with the 10 degrees. So 10 degrees multiplied by P over 180. We, of course, substitute that. So through radians, this angle is going to be P over 18. That's it. Now moving on to subsection B. 20 degrees, we multiply by P over 180. We divide by 2, we obtain 90. Here we again divide by 2, 5, divide by 2, 45, 5 and 9. So it's P over 9. Yeah, P over 9. So 20 degrees is P over 9. It's that easy. It's simple. Now the C example. 165 degrees multiplied by P over 180 degrees. First, we multiply by 5. We obtain 3 and 3. And here we obtain 3 and 6. Now again, we divide by 3. We obtain 11, and here we obtain 12. So 11P over 12. And yeah, we can write it as radians. Yeah, radians. It's not necessary every time, but it's good. The D subsection is minus 220. Minus 220 multiplied by P over 180 degrees. Divide by 2, 1 fifth, divide by 2, 90. Divide by, we can divide by 3, 30. Here is 3 and 5. Divide by 5, 7. Divide by 5, 6. So we have 7P over 6 radians. But with minus, yeah? Because we have the minus sign here. Do not forget the minus sign. And now we have the last subsection, E, which is 315. 315 multiplied by P over 180. We divide this by, firstly by 5, okay? We obtain 6, 3, and here we obtain 3, 6, yeah? Then divide by 3, 21, divide by 3, 12, Now by 3, 7, by 3, 4. So it's equal 7p over 4 radians. Yeah, and that's it. So that's the exercise. I think that this exercise is clear. Of course, you can do the opposite transition if you want. Just remember this. When you have angle 1 degree, this is the basic example. We multiplied by p over 180 to convert it into a p over 180 radians, to convert it into radians. And the opposite, if you want to convert radians into angles, which we will do in the next exercise, we multiply by 180 over p, so the opposite, and we will convert this into an angle. So now we'll do just the opposite. So now we'll do actually the transition from radians to angles. Yeah, expressed through um, degrees, these summarized angles. Okay, we are experts in that, so we are going to start with example A, p over 100 over 36. So the thing that we should do is simply, in other words, multiplying by 180 over p. But every time we do it, we are going to substitute this p. So only my advice is to only multiply it by 180, and you obtain 180 over 36, or you just substitute in the beginning. You know that p is 180, so you just do it as 180, sorry, over 36. You substitute and you get the value of the angle in degrees. Yeah, so here we divide by 3, we obtain 12. Here we divide by 3, we obtain 60. Divide by 3 is 24, and we obtain 5 degrees. So the angle is 5 degrees. Yeah, the first angle. Then B, 5p over 12. Again, we just substitute. Yeah. This divided by, can we divide it by 4? Yeah. We obtain 4, 5, and here 3. So here we obtain 15. So 5 multiplied by 15 is 75 degrees. So this is 75 degrees is this angle. C, 5p over 4. Okay, 5 multiplied by 880 over 4. Divide by 4 is 45, isn't it? So 5 by 5 is 25. 225 degrees is the answer. So it's that simple, you see that it's so simple, so there's not something that you should be afraid of. Now, minus 9p over 4 is minus 9 multiplied by 180 over 4. This is 45, and you obtain minus 9 multiplied by 5 is 45, 36, 405 degrees, minus 405 degrees, yeah. And the last example, yeah, we forget the, so 7p over 3. This is 7 multiplied by 880 over 3, 60. 7 multiplied by 60 is 420 degrees. So that's it. That's the answer. That's the whole exercise. So just remember that if we want to convert an angle like a degrees into a radian, we multiply it by p over 180. And if you want to convert radians into degrees, into angles, yeah, it's more correct to say in degrees, we multiply by the opposite, 880 over p. So that's it. Now, I think we should move on to more complex exercises. And they're not more complex, but they're again connected with that. And the task is for us to find the values of the trigonometric functions of the summarized angles. First, we begin with minus 600 and minus 600 degrees. So what's the idea here? The idea is that we want to find the value of the trigonometric function. That means that we should use the trigonometric table firstly, because there's no way, yeah, if we remember the values, we can directly substitute them when we obtain the sinus and cosine and tangent and cotangent. But if we don't know them, we should actually use the trigonometric table. So now I'll show you what we should do. Again, we should write it at the form that we wrote the exercises just a couple of minutes ago when we talked about these exercises specifically. This we write them in. We wrote the expressions. We wrote the measures of the summarized angles in this form. So now, first thing that we should do is to write them in this form. How can we write minus 600 degrees? Of course, we can write it as a 30 degrees minus, no, no. Sorry about that. But we can write them as, how we can do it. For example, I'm not quite sure, but yeah. So, 120 degrees minus 2 times 360 degrees. Yeah. So it's 720 minus, it's going to be minus 720 plus 120, it's going to be minus 60. And now we put this into the functions. We know that we have 4 functions: sinus, cosine, tangent, and cotangent. So sinus of 180 degrees minus 2 multiplied by 360 degrees. We know, because this is a repeated cycle, we don't need this. This is a repeated cycle. This is a repeating rotation in the unit circle. We don't need this. We need the degrees which are remained. So we remain with only this 220 degrees. So sinus of 120 degrees. And we look at the trigonometric table and we see that the value of the sinus when it is 120 degrees is square root of 3 over 2. And that is the solution simply. Yeah. Now we are doing again the same thing with cosine, and we are using this, which we obtained after writing the measure of the summarized angle in this form. So now we do the next function, cosine of 112 minus 2 times 360. This is again rotation, so only cosine of 180 degrees. You know, when you look at the table, this is minus 1/2. So that's the answer. Yeah. Now we are using this to find the tangent and cotangent. I will show you 2 ways. First, we can find tangent and cotangent using the fact that they are sinus over cosine and cosine over sinus respectively. But another way is to use that tangent of alpha minus k multiplied by 100 degrees is the form of the tangent, and the same form is for cotangent. You know, because their cycle is only the half of the unit circle, we write them as a multiplication of k, a constant, by 180, not by 360. You should remember that. So let's do it in by using the two ways. We are using first the first way, and it's like that. Tangent is equal sinus over cosine. We obtained sinus to be square root of 3 over 2 and cosine to be minus 1 half. We remove the denominator and we obtain minus square root of 3 over 1 or only minus square root of 3. The same for cotangent. Cotangent is going to be cosine over sinus because we know that. We know that cosine is minus 1 half and sinus is square root of 3 over 2. We remove the denominator and we obtain minus 1 over square root of 3. When we summarize, when we rationalize, we obtain minus square root of 3 over 3. And this is the value of cotangent. Yeah, so these are the correct values, but the second way that we are going to use, I think it's also good. We should think how we can write this angle minus 600 as in the form for tangent and cotangent. We can write it as 4 times multiplied by 180 degrees. Because 5 multiplied by 180 is going to be equal to, again, 720. So, again, we are going to write 180 minus 720. Yeah, but here we're going to do it instead of 2 multiplied by 360, we're going to do it like 4 multiplied by 180. It's the same for cotangent. Now, because these two are cycles, we remove them and we obtain only tangent of 108 and 20 degrees, which is minus square root of 3 when we look at the trigonometric table, and cotangent of 120 degrees, which is minus square root of 3 over 3. And we obtained the same value using that tangent is sinus over cosine and cotangent is cosine over sinus. So there's no way how it's more correct, but both ways are correct. But I think the first way is easier, like using the tangent is sinus over cosine if we have already found the values of sinus and cosine. But if we did not, we can use this. So it will be easier for us to calculate the expression. Yeah. So now we're moving on to an easy exercise, and it is define in which quadrant is the second leg of the angles. So we should imagine the unit circle. This is easy exercise. Imagine the unit circle. Sorry. Yeah, imagine the unit circle here and here, x, y. Of course, here that this is the first quadrant, this is the second, this is the third, this is the fourth quadrant. Of course, you should know, everybody should know, that here sinus and cosine are both positive. Here sinus is positive and cosine is negative because it's the left-hand side of the x-axis. That means that the numbers are negative. Here both sinus and cosine are negative because they are in the negative part of the coordinate system, and here sinus is negative again because it's in its negative part, and cosine is positive because here is the set of the positive numbers. So we should remember that, and we should remember that here is the 90 degrees angle. Here is the 0 equal to 360 degree angle. Here is the 180-degree angle. Here is the 270-degree angle. And we should imagine, for example, here is the A subsection. So we have subsection A. Subsection A is given to be 800 degrees. So we do the rotation. Yeah. So we do the rotation. The rotation starts from here because it's a positive degree. Sorry, starts from here, rotates one cycle. Here 360. Then we're doing a second cycle from here to here again, 720. Now we're adding 80 more degrees. And because we are not reaching these 90 degrees, we are somewhere here. So we are yet located in the first quadrant. Yeah, we are nearby the 90 degrees, but we do not cross them, we do not go beyond them, so we are in the first quadrant. Now the second subsection B is minus 160, 1160. And now because we know that the 100 degrees are in the first quadrant, yeah, let's imagine a new unit circle because we should visualize that. Here I'm gonna make it bigger. The coordinate system, the x-axis and the ordinate axis. Of course, you know 90, 180, 270, and 360 also equal to 0. So now, start here, rotate to here, 360. Then start here again, rotate one more time, 720. Then rotate one more time from here to here. We obtain 100 of 1180. Yeah, because you know 300 and yeah, actually 360 multiplied by 3 is 1080. Yeah. So now we are here, 1080, but we should have 18 more degrees. We are again reaching this part of the unit circle. So we obtain that it is in the first quadrant. But it's not. Why? Because we are given that the angle is negative. That means it's going to be just in the opposite quadrant. So that means in the fourth quadrant. In other words, we can visualize it directly, or erase this, directly by doing the correct rotation. How we do that? We start here and we do cycle counterclockwise. So here is 360 with minus. Then we do another rotation. From here, another rotation to here, minus 720. One more rotation from here to here again, minus 180. And we need minus 80 degree more. So we need from here to somewhere here. Yeah, because here it's 19. This is equal to minus 19. It's like the minus 90 degrees in the opposite way. So we should be located somewhere here, and this is the fourth quadrant. So the answer is fourth quadrant. Now doing the same with subsection C. Let's see what we have here. we have that the angle is 1,320 degrees. Okay, because we have this, we draw the unit circle, draw the coordinate system also, x, y, 90. Here we don't need the negative values of the angles because we have them. Because we have a positive angle. So we know that after 3 rotations, 1, 2, 3, we will obtain 180. After one more rotation, we will obtain 300, 1,440. But we have 1,320. So first, as we are here, let's come. Sorry, it is my mistake. I actually did the rotation in the wrong side. So I start here and I rotate like that, counterclockwise. So after 3 rotations, here, I start here, 1 rotation, 2 rotations, 3 rotations. Here I am 180 degrees. Now if I start from here and come to here, just at the intersection point with the 90 degrees, I will obtain 1,170. Then after one more, after I begin from here and move to here at the intersection point, I will obtain 1,260. Yeah. Then after starting from here, moving to here, I need 60 degrees more. So I will be somewhere here and I will do 1,360 degrees somewhere in 20 degrees, somewhere in the third quadrant. So this is located in the third quadrant. So it's that simple. Yeah, it's in the third quadrant. Now, the last thing for this video is going to be a last angle for this exercise particularly. This is the angle 3,730 degrees. Because we can't actually rotate till infinity, I think it will be easier to use the rotation till now. We know that if we have the actually the the unit circle and draw the coordinate system and name the ordinate and the abscess axis, the most easier thing for us will be to multiply 360 by a number k, and we will obtain how many rotations we have till reaching these numbers. How a full rotation. Because we know the number is 3,730, we multiply 360 by 10 and we obtain 3,060. So this is the closest thing. As if we write 360, we obtain a bigger number. So we have 10 full cycles, 10 full rotations. From here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rotation. And here we are at 360 degrees. 3,600 degrees. But we need 130 degrees more. So from here to here, it's 3,690, and we need 40 degrees more. So we continue here, and somewhere here in the second quadrant, we obtain 307,030 degrees. 3,730 130 degrees. So it's going to be somewhere in the second quadrant. And that's it. So it's that simple actually to visualize and to see where the angles are located. Here, the same thing you could do, you can do here by using, for example, that not four, yeah, 4 times multiplied by 360 is giving us 1,440. 1,440 minus 112 and 20 will give 1,320. Yeah. So we do the full cycles and then we do negative minus 120 degrees. So from here, like if we have the unit circle and if we have the cycles, yeah, 1, 2, 3, 4, from the fourth cycle, as we do it counterclockwise, we continue to do it clockwise. From here to here, it's minus 90, but we need minus 120. So a little more, and we come to the fourth quadrant, which is not the fourth quadrant, but the third quadrant, which is actually our answer. So this is also a way. Of course, you can do it like 180, which is 3 times 360, plus 2,240. So you do in that situation, if you write it like that, you're going to have 3 full cycles. Yeah. Here is the first, second, and the third cycle. And here's going to be 180 degrees, and you need 240 degrees more. You know that here is the 270, here is the 180. So you immediately should know that angle 240 is somewhere here between 180 and 270. It's somewhere in here. So that means it's somewhere in the third quadrant. So there are so many ways that you can do these things, but these are the basic ones. And I would prefer to do this, like multiplying 360 by a specific number, as closer as you can to your given angle, to your given degrees, and then subtract or add to this value, add some angle, and in that way it will be easier for you to actually understand in which quadrant are the angles located. Yeah. So I think that was all for today. And I hope that this video was helpful for you. I hope that you have understand something. For example, today we went through the exercises where we should write angles in a specific form. Of course, we went through the measures of a summarized angles and how we can write them in a specific form using an angle which is in an interval, in a specific interval. Here it's in the interval of minus 180 to 180. Also, we went through how we express angles through radians and how we express radians through angles. We went through how we find the values of a trigonometric functions when we are given the value of the summarized angle. And we went through on how we can define in which quadrant a given angle is located. So that's it for today, guys. I hope that this video was helpful. At least it was interesting for watching. On the next video, we are going to prove that some values of trigonometric functions of a summarized angles and, for example, angle A alpha and angle beta are equal if, and we are giving some degrees, yeah, angles. We are giving some angles and their degrees, and we should prove that these two angles, their values of their trigonometric functions are equal. So we're going to do this in the next video, which I'm going to post tomorrow. Thank you guys. See you tomorrow. See you in the next video, and put down in the comments uh your opinion on how you find this video. Do you find it beneficial in any way? How can I improve? How can I explain in a better way if it was not clear? Or yeah. Or also you can write in the comments which type of exercises do you want to specify on, and which types of exercises do you want to see in this channel. Because if you give me an ideas, I will be able to do them, yeah. So if you tell me which type of exercises are hard for you, maybe I can change the topic from trigonometry to, for example, combinatorics or something like that, or geometry if you have a geometry question. Also, you can post exercises down in the comments if you can, or I don't know how YouTube works now, but I would think of it how you can send me exercises, and maybe I can do videos of your exercises and how I can personally solve them. Of course, um, have in mind that I am 11th grade, so you should give me exercises that I can solve. Um, so I'm 11th grade here in Bulgaria, so that means that's the pre-last year of high school. So you should uh, be careful when you give me exercise, because there could be some exercises that I can solve because they're not my level or something like that. So yeah, guys, thank you very much again, and yeah, see you tomorrow.